Welcome back, everyone. Today we'll be discussing units of measurement. The learning outcomes of today's video are to define what is a unit, to differentiate between SI and English units, and then finally to evaluate measurement sizes based off of SI prefixes. So science and environmental geology is composed of both qualitative and quantitative measurements. Qualitative measurements are more subjective. They can be observations, a certain color or feeling that is evoked. A quantitative measurement is more definitive, and it's based off of an agreed upon set of units. It's absolute. I can take a measurement in meters and compare it to someone else's measurement of meters, and these should agree because there's no subjectivity to it. A good example are earthquakes are measured by intensity. On the right here, we have a map of the intensity of the 1906 San Francisco earthquake, which had a magnitude of 7.8. That's a quantitative measurement based off of the amplitude felt by a seismograph of different P and S waves. So that's absolute. The magnitude is 7.8. But earthquakes are also measured by intensity. And so the coloring here is what the feeling of the earthquake was to people. If people aren't around to feel an earthquake, it has a really low intensity because it's all based off of perceived shaking. In these red regions, we have extreme perceived shaking and lots of damage to human buildings. And so it's said to have a high intensity. Whereas in these blue regions, it has a light intensity. There was light shaking, there was no damage to structures, but all of this is registered and interpreted by people in those areas. Both of them have their value. We can look at manuscripts from thousands of years ago and compare what was written down, the written word, convert that into an intensity and start to compare it to the earthquakes that we have in modern times and times where we have written science and seismology. So both have their value, but today we're going to focus on units that are used in quantitative measurements. Units are a measurement or magnitude of a quantity. If I want to describe time, I might use days. If I were to describe the time it takes to undergo a chemical reaction, I might use milliseconds or picoseconds, something really, really small because those happen so quickly. If I was to describe the movement of a glacier, I might use years or even decades, millennia to describe the movement of that glacier. So units are a magnitude of a quantity, but make sure you're using the correct magnitude for the given problem. We're going to look at entire ecosystems, which are going to be described in square kilometers. Those are enormous units of area or distance. But then we might move down to a small stream, which would be described in a distance of meters or area of square meters. Volume, our measurement of volume uses units of liters or gallons. Ounces, fluid ounces are units of volume. And so all of these different measurements, all these different quantities are described with units that fall into two different systems. We have the International System of Units, SI units, which is used by a wide majority of the Earth. And then we have English or the imperial system, which is used mainly by the United States and some select other countries in certain circumstances. Here's the comparison of that. Here we have our measurement of distance for an SI unit. The base unit for that, these are base units here. We have meters, liters, and grams. And based off of what prefix we add to an SI unit, I can make this centimeters, and that's a smaller unit by just adding the prefix centa. In terms of grams, I can make it a smaller unit of mass by adding milli and use milligrams. English units are less intuitive in that regard. Inches to feet is you multiply by 12. From feet to miles, you have to multiply by 5,280. And so we won't be using these so much in this course, but know that they exist. And environmental geology and any science that interfaces with the public especially in the United States, has to use English units. So you can conduct all your research in SI units and find results in meters or grams, let's say. But if you want something to be built, if you want it to be interpreted by the local government or a builder in that area, your house is built using inches and feet, not meters. So if you want to build something like a dam, let's say to impound a certain volume of water, you would have to convert everything into English units. And so I kind of enjoy that aspect of balancing and moving between SI units and English units, because in our field, you really have to know both and use both pretty interchangeably. But like I said, we're going to focus on SI units because of their use of prefixes. So if you add a giga or a G in front of a base unit, you are describing 1 billion of that unit. So gigabyte is a common usage of this prefix. That means there is 1 billion bytes. Kilometers, a kilometer is 1,000 meters. A centimeter is 1/100th of a meter. It's a smaller unit. We start moving into different prefixes as we get smaller. A milligram is 1,000th of a gram. So you can add these prefixes to either meter, grams, or liters and start to convert between larger areas where we would describe whole ecosystems to more chemistry and smaller systems. So I'd like to work through an example of this with you. Which is larger, 1,000 decameters or 0.1 megameters? So first, I'm going to recommend that you convert it into our base unit. So we know that deca is 10 times, it's 10 meters. A decameter contains 10 meters in it. And so that means 1,000 decameters is equivalent to 10,000 meters. A megameter is equivalent to 1 million meters, 1 million meters. And I can describe that by 10 to the 6th is equivalent to 1 million. But we have 0.1 of that. We have 0.1 of a megameter. And so I'll multiply by my 1 million meters by 0.1. By 0.1. And that gets me 1/10 of a million is 100,000. So which one is bigger in this case? That would be our 0.1 megameters. 0.1 megameters is larger. It's greater than. If I were to multiply these two values together or have to do any type of math with these units, I would like to convert these into base units before I start multiplying these together, or convert them into like units so that you end up with a value that is like. And that concludes our video. Let me know if you have any questions on Canvas. Thank you.